Hello and welcome to another exam paper walkthrough. Today, thank you very much for joining me. Today I'm going to be looking at a GCSE past paper. The past papers are fantastic revision for any exam series that's upcoming. One of the best forms of revision in my opinion. Today I'm going to be focusing on an AQA paper and I'm going to be focusing on June 23 paper 1H, so a non-calculator higher paper. This will be fantastic revision for any exam board, but this is a past AQA paper. Attached to the description to this video, you will find a link to a Google Drive where you can download a copy of this paper if you've not already got the paper. I would strongly recommend either doing the paper before watching the video or doing it alongside. Kind of try a question, watch how you do the question, and so on. I'd also recommend a bit of music on in the background. I always record these videos with an earpod in, listening to a bit of music. And if you find this video useful, please do subscribe if you like, and you'll get notifications as soon as any other material is posted. Right, before I get into the paper, I'm just going to very briefly talk you through the question level analysis for this paper when it was sat. And I've also introduced, I've just purchased for my school Sparx Maths. So these are all the topics that were covered on the 27 questions within this paper, and these are the Sparx codes to each one of those questions. So if you're particularly struggling on, let's say, for example, question 9, criticising reciprocal graphs, you can get additional revision for this by using the Sparx code U593. This is also quite useful because it gives you the grade boundaries for this paper, and it also tells you how well each grade student found these questions. So, for example, for the grade 9 students, this one was viewed as the lowest scoring. So that was question 15. And that was pretty much across the board for all of those. So the questions are designed to be in order of difficulty, but they don't really know how that hits until students have actually sat the papers. So it's quite useful in terms of finding how well done the questions were for other students. Right, enough of me talking about that, and we will start the paper. Okay then, right, let's start with question 1. Work out 0.7 times by 0.5. So my method for this is I always tend to just view it as the normal digits. So 7 times by 5 would be 35. Now, these are actually both divided by 10, so this would be divided by 100. I tend to view it, though, in my head as I've ignored 2 decimal places. I've ignored 2 decimal places, so I need to put 2 into my answer. So it's going to be 0.35. Right, part B. Part B, work out 5/6 divided by 3. So if I'm dividing by 3, I'm going to treat this as 5/6. Instead of divided by 3, I'm going to view it as 3 over 1. And then I'm going to change that to 5/6 times by multiplying by the reciprocal. So dividing by a fraction is the same as multiplying by the reciprocal. And then this is just a lot more straightforward. So 5/6 times by 1/6 is going to be, times by 1/3 would just be 5 over 18. Part C, work out 27 divided by 0.6. So I don't like dividing by decimal, so I'm going to times both the, if I view it as 27 divided by 0.6 or over 0.6, if I times the numerator and the denominator by 10, that would give me 270 divided by 6. And I know 27 divided by 6 is going to give me, so I'm going to do that sum. So 6 is divided by 270. So 6 is, don't go into 2. 6 is going to 27 4 times. 6 times 4 is 24. 25, 26, 27. So I've got 5 remain. I've got 4. I've got 3 remainder. And then 6 is going to 30 45 times, so my answer is just 45. Right, question 2. Solve 2x is less than 26. So I'm going to divide both sides by 2 and say x is less than 13. So that's going to be my answer. So x is less than 13. Question 3, work out the value of 3 over 2 squared, given your answer as a mixed number. So I'm going to treat it as 3 squared over 2 squared, which is going to give me 3 squared is 9 and 2 squared is 4. So 9 over 4. Given your answer as a mixed number, so 4's go fully into 9 twice, with 1 left over, which is still divided by 4. So 4 and a quarter. Right, question 4, ABC, ABC, BD, and EBE are straight lines. Okay. The angle EBD is 5 times the angle ABE. The angle DBC is 3 times the angle ABE. Work out the size of angle EBD. Right, so I'm going to introduce algebra to help me out with this. So if I call this angle X, then EBD is 5 lots of angle ABE, so that would be 5x. And angle DBC is 3 lots, so that would be 3x. So those angles need to add up to 180. So that's going to be 9x is equal to 180. So divide both sides by 9x would be equal to 20. That's not actually the angle that I wanted. I wanted 5x. So I wanted EBD. So that's going to be 5 times 20. So that would be 100 degrees. Question 5. 2 prime numbers are multiplied together. The answer is an even number between 50 and 60. Complete the calculation. Well, for 2 things to multiply together to make an even number, either both of them are even, which we can't have because we've only got one even prime number, or one is even and one is odd. So we've got to have an even prime number. There's only one even prime number, so 2. 2 times by, so I'm after a prime number bigger than 25. So I think 25 can't be, 26 can't be, 27 can't be, 28 can't be, 29. So I think it's going to be 2 times by 29, and that's going to give you 58. Question 6. Andrew and Bruce share some money in the ratio of 5 to 6. Bruce gets £96. Andrew gives a quarter of his money to Carl. Bruce gives 2/3 of his money to Carl. How much does Carl receive? Right, so we've actually got 3 parts to this ratio, A, B, and C. First part tells us that the ratio is 5 to 6 and that Bruce gets £96. So I'm going to work out Carl's amount. So I'm going to do 96 divided by 6. So 9's go into 96 fully. Well, goes into 9 once, 3. So it goes in 16 times. And then 16 times by 5 is 80. So that means that Andrew gets 80 to start with. Bruce gets 96 to start with. So if Andrew gives a quarter of his money to Carl, so a quarter of this is going to be, so 80 times by 1/4, and I'll put in the full sum, and then to that I want to add, Bruce gives 2/3 of his share to Carl, so I want to do 96 times by 2/3. Right, so 80 times by a quarter is going to be £20, and then 96 divided by 3 is going to give me 32. 32 times by 2 is going to give me 64. So that's going to be £84. Okay, work out the value of a. So 2 to the power a times by 3 times by 5 squared is equal to 600. Work out the value of a. So we could do 600 divided by 3 times 5 squared. Alternatively, the way I think is probably going to be easiest is to break this down into its prime factors. So 600 is 2 times by 300, which is going to be 2 times by 150, which is going to be 2 times by 75. And to be fair, none of the rest of that is divisible by 2, so we can stop there. So A has got to be equal to 3, because it's going to be 2 times 2 times 2 times 75. 75 is obviously 3 times 5 times 5, but that's absolutely fine. We don't need to go any further than that. Right, question 8. Expand and simplify fully this. So I'm going to expand each bracket first of all. So 5 times by 3x would give me 15x. 5 times by 4 would give me plus 20. And then minus 2 times by x would give me 2x. Then we've got a double negative to watch out for. Minus 2 times minus 1 is plus 2. Right, so 15x, take away 2x is going to be 13x. And then 20 plus 2 is going to be 22. So I'm looking at 13x plus 22. Right, question 9. Erica sketches the curve of the graph y is equal to 1 over x, where x is not equal to 0. Make 2 criticisms of her graph. This is going to be a reciprocal graph. So a reciprocal graph should look like this. So my 2 issues are this part here, and then secondly, this part here. The whole of this curve should be here. So the way I'm going to do this, I'm going to call this curve 1 and curve 2. So I'm going to say my first issue is that curve 1 should not touch the y-axis. So curve 1 should not touch y-axis. And secondly, curve 2 needs to be reflected in the x-axis. So that's going to be my 2 criticisms. Question 10. Sunita is X years old. Beth is 1 year younger than Sunita. Joel is double Sunita's age. The mean of their age is 5. How old is Joel? Okay, so Sunita is X. Beth is 1 year younger, so that would be X minus 1. Joel is double Sunita's age, so that would be 2X. Right, the mean of their age is 5. Right, so that means that these 3 ages, so x plus x minus 1 plus 2x, has to add up to 3 times the mean. So x plus 2x is going to be 4x minus 1 has to be equal to 15. So that means that then 4x is equal to 16. I'm going to take a bit of a shortcut here. I want Joel's age, so I actually just want 2x. So 2x is going to be equal to half of that, so 8. So Joel will be 8. Question 11. The Venn diagram represents 100 items. Write down P, A, and B. So that means the probability of the intersection of A and B. So that is 13 out of the number of items. So that would be 13 out of 100. Right. P, A dashed means the complement of A. So the complement of A is going to be 48 plus 11 out of 100. So that would be 59 out of 100. and then work out the probability of AUB. So that's the union of A and B. So that is everything that is within A and B. Right, I'm going to take a mini shortcut here. I'm going to say that that's going to be 100 minus 11 over 100. So just to explain that, all of them need to add up to 100. Rather than add these three numbers, I'm just going to do 100 minus 11. So that's going to give me 89 out of 100. Right, question 12. A times 10 to the power n is a number in standard form. Complete the inequality for the value of A. So the number part has to be greater than or equal to 1, but less than 10. Part B. B times 10 to the n is the number 7,200 written in standard form. Work at b times 10 to the minus n. Write your answer as an ordinary number. Okay, so first of all, I'm going to write this number. So this number would be 7.2 times 10 to the power 3. So if I want to write the number 7.2 times 10 to the minus 3, that's going to become 0.00, so 3 zeros in front of the number, 72, so 0.0072. Question 13. Here is a number machine. Input output. Show that when the input increases by 2, the output increases by 2a. Okay, right. So if I just very basically do my input, and my output. If I put x in as my input, then my output is going to be 2 ax plus b would be my output. Now, if I put x plus 2 in as my input, my output is going to be a times x plus 2 plus b, and that's going to be equal to, I'm going to write it like this, 2a plus ax plus b. Right, and then if I do, I probably should have done this with just normal numbers, 2a plus ax plus b, subtract my other value, ax plus b. That's going to just give me 2a, which I think is perfectly fine. I've done it using algebra. You could have, in theory, put a number in for both, but I'm going to stick with that. Right, part B, function of x is equal to kx squared, where k is a constant. Kaya says that f of 2 divided by f of 6 divided by f of 2 is equal to f of 3 because 6 divided by 2 is equal to 3. Is he correct? Show working to support your answer. So that's not really how functions work. So I will actually work out the value of f to the 6 is going to be equal to k times 6 squared. So that's going to be 36k. And then f of 2 is going to be equal to k times by 2 squared, which is going to be equal to 4k. And then so f of 6 divided by f of 2 is going to be equal to 36k divided by 4k, which is going to be equal to 9. I'm not fully sure that I've actually got my full work in there because we don't know that f of 3 isn't equal to 9. So I'm also going to work out f of 3. So f of 3 is going to be equal to k times by 3 squared, which would be equal to 9k. So those aren't equal. So is he correct? No. F of 3 is equal to 9k, not 9. Question 14. Here is a list of 11 whole numbers in numerical order. The lower quartile, median, upper quartile, and highest value are missing. The median is 2 times the lower quartile. The upper quartile is 2.5 times the lower quartile, and the range is equal to 2 times the interquartile range. Complete the list. Okay, so I'm going to do this with a tiny bit of trial and improvement, I think, in numerical order. So we've got 5 values that this could be, we've got 6 values that this could be, and so on. Let's just imagine it was equal to 9 for a second. So the median is 2 times the lower quartile, so 18 there. That wouldn't work because that's not fitting. So we could have 10 and we could have 20. The range is 2 times the interquartile range. So could that work? Upper quartile is 2.5, the lower quartile. So if the lower quartile was 10, 2 times that would be 25, which wouldn't work. And that's going to give me a hint for my next one. There's no point in me trying 11 because that would create a decimal here. So the next one I'm going to try, well, hopefully the last one I can try is 12. Actually, no, it couldn't have been 8. It could, in theory, be 13, but we'll see whether this 12 works. So the median is 2 times the lower quartile, so 24, that would work. And then 2.5 times the lower quartile. So 2.5 times that would be 24 plus 6 would be 30. So that does work. And then the range is 2 times the interquartile range. So the interquartile range is currently 18. So 18 times by 2 would be 36. And then that would be the range. So 36 plus 5 would be 41. So yeah, that's my combination that works. So I'm going 12, 24, 30, and 41. So 15, ABCD is a trapezium. All 4 sides are different lengths. AB is parallel to CD. The diagonals intersect at X. For each statement, tick the correct box. So triangle AXB and triangle CXD are similar. Well, that angle is going to be equal to that angle is going to be equal to that angle, and that angle is going to be equal to that angle. And they're not congruent because these are different lengths, so that one must be true. Triangles are congruent. They can't be true because we're told that we're told all 4 sides are different lengths, so not true. Angle ADB, so that's, let's change pen for this. So that's that angle. ADB, yeah, and BDC, BDC are equal. No, that one can't be true. No, that can't be equal. Let me just double check that in my head. BDC, BD, yeah, that one and that one. No, they can't be equal. Yeah, because No. If these are parallel, then we haven't got any alternate, really. Well, I mean, that one and those two angles can't be equal because those two sides aren't equal. Yeah, because these two sides aren't equal, because DA and AB are not equal, it can't be an isosceles triangle between AD and B, so that one can't be true. The area of ABC is equal to the area of ABD. That's going to be, can't be equal, because they've both got the same height, but they've both got different base lengths. So that one, let me just double check that. No, because we're doing AB. Sorry, I've missed. So ABD, ADB. So that's this triangle. And this triangle. No, let's go for a colour we haven't used. BDC. I've underlined the wrong one there. I'm not having a good one on this one, so I've done that right. Let me underline the right one though. That's that triangle, ABC. ABC, that's that triangle. And triangle ABD, so that is that triangle ABD. Right, now interestingly, they both have the same base length and they both have the same perpendicular height. So those areas must be equal. So that one is true. So there we go. True, not true, not true, true. Right, question 16. Solve the simultaneous equation 2x minus 5y is equal to 13 and 3x plus 4y is equal to 8. So I either want to make my x coefficients the same, the lowest common multiple of those two would be 6, or make my y coefficients the same, and the lowest common multiple of those two numbers would be 20. So I'm going to make my x coefficients the same. So I'm going to times the first equation by 3 and the second equation by 2. That would give me then 6x minus 15y is equal to 39. I'll call that equation, technically that was 1, that was 2, so I'll call that equation 3. And then I'm going to times the second equation by 2, so that would give me 6x plus 8y is equal to 16, and I'll call that equation 4. Now, to get rid of my x coefficients, I'm going to subtract 1 from the other. I'm going to do it this way around, 4 minus 3. 4 minus 3. Reason for that is I've got a minus coefficient here. So if I subtract a negative coefficient, it is equivalent to adding that coefficient. So 6x minus 6x is 0. 5y minus negative or minus 15y is going to be 23y. And 16 minus 29 is going to be minus 23. So divide both sides by 23, y would be equal to minus 1. Right, I'm now going to sub that value for y into my first equation. First equation or second equation, doesn't really matter. We'll go for the first equation. So that is then that 2x minus 5 lots of minus 1 would just be plus 5. Is equal to 13. Minus 5 from both sides, 2x is equal to 8. So x is going to be equal to 4. I'm going to do a real quick check with equation 2 because I used 1 there. So equation 2 said that 3 lots of x would be 3 times 4 would be 12. Plus 4 lots of y, so that would be minus 4. Is equal to 8, and it should be equal to 8, so I know that I've got that right. So x is 4, y is minus 1. And if you made your y coefficients the same, that's absolutely fine. It's just another method, but that's how I would do that one. Question 17. A solid hemisphere has a radius of x, a solid cylinder has a radius of 3x and a height of x. Surface area of a sphere is 4 pi r squared, where r is the radius. Work out the ratio of the total surface area of the hemisphere to the total surface area of the cylinder, giving your answer in its simplest form. Okay, so I'm going to start with the surface area of the hemisphere. This is for a sphere, so hemisphere is half a sphere. So the surface area of the hemisphere, I'm going to call that HS, is going to be equal to half of this, so that would be 2 pi x squared. I'd also need to add on pi r squared, so pi times r squared, so pi x squared. So the total surface area of that is going to be then 2 pi x squared plus pi x squared would give me 3 pi x squared. Right, the surface area of the cylinder, I'm going to call, we'll change pen colour for this, we'll go blue. So the surface area of the cylinder is going to be equal to 2 lots of the circle, so that would be 2 times pi times r, which is 3x squared, plus the dimensions of this would be x. So if you imagine what we'd actually have is, so that's where the 2 pi r's have come from, 2 pi r squareds have come from, but now this is x, and this length here is the circumference of the circle, which is 2 pi r. This is going to be x times by 2 pi r, so 2 times pi times x. Right, so this is going to give me 2 times 9, that's going to give me 18 pi x squared, plus 2 pi x squared, which is going to give me 20 pi x squared. I've just spotted a slight mistake that I made here. This shouldn't be x, this should be 3x, because the radius of the circle is 3x. So that should be x times pi r times 3x, because x is the radius. So that would actually not be 2 pi r, that would be 6 pi, so that would be 24 pi x squared. Right, so we want to express this in its simplest form. So we've got total surface area of the hemisphere to surface area of the cylinder. So we've got 3 pi x squared to 24 pi x squared. And we can cancel the pi x squared on both sides. And then we can actually cancel by 3 as well. So that's going to be just 1 to 8. So my answer is 1 to 8. Apologies for that slight mistake with the radius of the circle that I hit there. Right. Question 18. Circle the possible values of x. So 6 is less than cube root of x, which is less than 7. So the way I'm going to do this is if I mean, it's only a 1 mark question. If I just said roughly what's the size of these roughly? So I would want to do 36 times 6 and 49 times 7. So the easiest one to hit 50 times 7. 50 times 7 is going to be 350. So we're looking for a number, and then this is going to be, let's say, roughly the same as 40 times 5, which would be 200. So we're looking for a number between 200 and 350. So that's going to be my value, just using a bit of estimation. Question 19. Work out how many 5-digit odd numbers can be made using these digits once each. Do not list them. Okay, so we've only got 2 odd digits here. So the way I'm going to tackle this is if I just imagined it ended in 7, so blank, 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 7. The number of combinations here would be, there would be 4 times 3 times 2. So there would be 4 times 3 times 2, which would be 24. And then actually we're going to have, because we've got blank, 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 9, there's going to be 2 lots of that. So I would really need times by 2, times by 2. So that's going to be 48. There are going to be 48 possible combinations. Question 20, K, L, and M are weights. Both of the scales are exactly balanced. How many M weights are needed to balance 1 L weight? Right, so let's kind of view this then. We've got 3K is equal to 4L. And then we've got K is equal to L plus 2M. How many M weights are needed to balance 1 L weight? So we want to end up with L equals, and then something involving M. So I've miswritten my L. It looks like a number 4 there. So essentially what we want to do then is get rid of K from both equations. So if I just manipulate this slightly and say K is going to be equal to 4/3 of L, I can then substitute that into here. So I'm going to say then that, let's change pen color. So I'm going to say then that 4/3 of L is equal to L plus 2M. Not particularly needed. How I'm going to solve this, I'm going to times through by 3 to start with. So 4L is equal to 3L plus 6M. And then if I minus 3 from both sides, that gives me L is equal to 6M. So L is 6M. The question said how many M weights are needed to balance 1L, so that's just 6. Okay, complete the square question. So express x squared minus 6x minus 15 in the form of x minus a all squared minus b. So I'm going to view it, I'm just going to go straight for it. So it's going to be x minus half of this coefficient all squared. However, this compared to this, we would have to minus 9 from it, and we've still got minus 15. So when we fully do it, we're going to have x minus 3 all squared minus 25. Sorry, 24, not 25. Question 22. A is equal to root 2 and B is equal to root 18. Match each of the expressions to its value. The first one has been done for you. Okay, so what I'm going to do is just express this slightly differently. So that would be 9 times 2, so that would be 3 root 2. Right, 3 root 2 plus 3 root 2 is going to be 4 root 2, so that one would match to that one. If we multiply them together, then root 2 times 3 root 2 would be the same as 3 times 2, which would give me 6. And then a over b, so 3 root 2 divided by root 2 would just give me 3. Question 23, right? 0.13 reoccurring as a fraction in its simplest form. I love these. So we're going to start by calling the first value x, 0.13 reoccurring. Now, I know a lot of people do this differently. I will only times this by, because it's a 1 decimal reoccurring pattern, I will times this by 10 to give me 1.33 reoccurring. I will then do this one, take away this one, so I'll say 9x is equal to 1.2. So x is going to be equal to 1.2 divided by 9. That's not technically a fraction in its simplest form. Well, when it's written as a fraction, we shouldn't really have a decimal within a fraction. So that's going to be the same as 12 over 90. I've just times the numerator and denominator by 10. And then we can cancel down by a factor of, we can actually cancel down by a factor of 6. So 6 goes into 12 twice, and 6 goes into 90 fully 15 times. So in its simplest form, we've got 2 over 15. Okay, so the points P and Q are and R, which is 8, 22, form a triangle, form a right angle triangle. PQ is a horizontal line, so this line here. Point P on the y-axis. Okay, right angle triangle, gradient of PR is 2. So that's the y equals 2x plus c. Work out the coordinate of Q. Okay, so I'm going to do this in 2 stages. The first thing I'm going to work out is the coordinate of P. To do that, all I need to do is to say, work out the value of C. So if I say, so we'll start by trying to work out the coordinate of P. We obviously know that it has an x coordinate of 0, but we don't, well, C. So we've got the line y is equal to 2x plus c, and we've got the coordinate 8, 22. So 22 is equal to 16 plus c. So c is going to be, and then if I minus 16 from both sides, that's going to give me c is equal to 6. Okay, so that means the point P is at 0, 6. And our Q coordinate must be something 6. I'm going to call it A for now. Right. So my starting to work out Q then. So Q is going to be equal to a 6. Right. Because this is a perpendicular line, so perpendicular gradients must multiply together to make -1. So that is going to be minus x over 2, or minus a half x, plus c. We're going to again use the coordinate 8, 22 to work out the value of c for this line. So 22 is going to be equal to -4 plus c. So if we add 4 to both sides, that's going to give me 26 is equal to c. So we've got the equation of the line now as y is equal to minus x over 2 plus 26, and we're substituting in the values of a and 6. So that means then that 6 is equal to minus a over 2 plus 26. I'm going to take my minus a over 2 to this side and my 6 to this side. So a over 2 is going to be equal to 20. Times both sides by 2, then a is going to be equal to 40. So the coordinate there then is going to be 40 and 6. Okay, show that 4 sine 30 minus tan 45 divided by 2 cos 30 can be written in the form tan x, where x is an acute angle. Okay, right, so first thing I'm going to do is sine 30 is equal to tan 45 is equal to, and cos 30 is equal to. Right, and I might need some other values later on in the question, but I'm going to stick with that. So I know that sine 30 is 1 over 2. Cos 30, so I'm doing this from the triangle, 2, 1, root 3, and I'm using this angle, that's 30. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, so 2 over root 3, which is the same as root. I've done that the wrong way around. Adjacent over hypotenuse, so root 3 over 2. For the 45, so we're going from a 1 by 1, that's root 2. So tan 45 is opposite over adjacent, so that would be 1. Right, okay. So we've got 4 lots of a half. So 4 lots of a half is going to be 2 minus 1 over 2 lots of root 3 over 2. So that is going to become 2 minus 1 is going to be just 1 over root 3. And we can do it straight from there. So if we look back to this triangle here, so we've got the tan of 30 would be opposite over adjacent. So that would be the tan of 30. So where x is an acute angle, so x would need to be 30. Can be written in tan x where x is an acute angle. So x equals 30. Right, question 26. A circle center O has a circumference of 20 pi. Q is a point on the circle. OPQR is a square. The perimeter of the square to the circumference of the circle is equal to root A to pi, where A is an integer. Work out the value of A. You must show your working. Okay, so we know the circumference of the circle, so we've already got this part here. What we need is the perimeter of the square. So to work out the perimeter of the square, first of all, I'm going to say that this is going to be the radius of the square. So I need to work out the radius of the square. So the circumference of the square is equal to pi r, 2 pi r, sorry, 2 pi r. And we know that that is 20 pi, because that's given to us in the question. Is going to be equal to 2 pi r. So if we divide both sides by 2 pi, we would get 10 is equal to r. So we know that the radius of the circle is equal to 10. Right. So based on Pythagoras, I'm going to call this length x for now. So I know that the radius squared is going to be equal to x squared plus x squared. And we know the radius is 10, so 100 is going to be equal to 2 lots of x squared. So 50 is going to be equal to x squared. So if I square root both sides, root 50, and we only want the positive value here because we're dealing with the length. So that would be 5 root 2 is equal to x. But we want the perimeter of the square, that's one of the values. So the perimeter is going to be 4x, would be 20 root 2. So the perimeter of the square, that would be 20 root 2 to the perimeter of the circle, which is 20 pi. Divide both sides by 20, we've got root 2 to pi. So A would be equal to 2. Question 27. A journey has 2 stages. So we've got stage 1, stage 2, distance, average speed and time, and we've got A and B for the average speed. Okay, so show that the average speed for the whole journey in kilometers per hour is 2AB over A plus B. Right, so the total distance is going to be equal to 30 plus 30. which is going to give us 60. The total time is going to be equal to 30 over A plus 30 over B. So that's going to be equal to, so if I put them over the same denominator of AB, so that would be, I'd need to times that by B, so that would be 30B plus 30A over AB. Which is, I can take 30 out as a common factor, 30A plus B, just tidying it up before I do anything with it. Right, so the average speed for the whole journey is going to be equal to distance divided by time. So the total speed is going to be equal to 60 divided by 30 A plus B over AB. So when you divide, it's the same as multiplying by the reciprocal, equivalent to multiplying by the reciprocal. So in a sense, that's going to become 60 AB over 30 A plus B. And then we can cancel down by a factor of 30, so that would be 2AB over A plus B, which hopefully is what we were asked to show. That is what we were asked to show. And there we go. So that's the end of the paper. Right, so before I sign off, I'll bring up the question level analysis again. Okay, so I brought this up at the start of the paper. I'll bring it up again. So this is the question level analysis from AQA from when the paper was sat. That gives you rough grade boundaries for the paper. You were looking at in that form, I think it was 73 for the 9 on that paper, 62 for an 8, 63, 53 for 7, and well, you can see the rest for yourself. That gives you a rough idea of how you did on that paper. You've also got that facility by grade, and again that geometric deduction with trapeziums hit as the kind of the shocker right in the middle of the paper. I hope you found that useful. The video should be chapter indexed, provided I've had time to do the chapter indexed by each of the topics. There's also, I'm going to also throw in the Sparx codes directly in there as well. If you need to do any independent study, that's the direction I would steer you in. Thank you very much for joining me. I hope you found it useful. And good luck with the rest of your revision. If you've got any questions, comments, or feedback, please just stick them in as a comment, and I'll get back to you fairly quickly with that. Other than that, thanks for your time, and I will see you soon.